Hello class. For this section, we're going to be talking about a binomial problem that's going to be approximated by a normal distribution. And here's the basic idea. So you technically have one condition, and in this case, NP greater than or equal to 5 and NQ greater than or equal to 5. And the second condition is NP and Q greater than or equal to 10. When both of these conditions are satisfied, then you technically have that the binomial problem happens to be in terms of shape bell shape, and it's perfectly bell shape. Now when you're looking at the binomial problem, these are the main parameters that we're going to be using, and that is that mu is equal to NP, sigma is equal to the square root of NP and Q. Now there is a minor technicality within both of these distributions, and that's due to the following. So your binomial problem is represented by the histogram. And the random variable, it's going to be starting at x is equal to 0 successes all the way to n successes. So it's not necessarily going to go to from negative infinity to positive infinity. Now, when we're talking about the normal distribution, your normal distribution goes from negative infinity in theory all the way to positive infinity. So to account for this discrepancy within the random variable, we're going to be using the following chart. And the chart here is used as follows. So nonetheless, we're going to be using the normal to approximate the binomial. So you first look at the binomial and see how each of those statements happens to be stated. If it's a statement of equality, then as you go to the normal distribution, you're going to be adding and subtracting 0.5 from the random variable. Now, let's take a look at this one. If they say within the binomial that x is just greater than a, then as you transition to the normal distribution, you're simply going to add 0.5 to the given value of a. And then any other calculations are going to be basically evaluated with mu and sigma from the binomial as you're doing the normal distribution. So once again, we're doing a little bit of a review from previous content where in this case you have a binomial problem and we're using the normal to approximate it.